Okay, we're back here with Sage where I typed those in, and yes, I wasn't actually connected to the network, I guess, and at that point, and so it wouldn't load. So I have those commands in that I had mentioned. I hit evaluate, and there's our derivative, our first derivative, minus 2x over x squared plus 1 quantity squared. And now I could do the same thing again and try to find the second derivative and then the third derivative. And so if I go in here and we'll just get each of the derivatives, I'll hit enter. So now I'll do f pp for f double prime, or second derivative, equals, and we'll use fp dot diff as before with respect to x, and so we have that back here, and then we'll show that. So show, the nice thing about show, you can also use print, but show makes it typeset a little nicer. Show f double prime, and close that parenthesis. And while we're at it, since I'm here, we'll go to triple prime. So f triple prime, and that is equal to f double prime dot diff oops, there we go, with respect to x. And where am I? Let's see, we need to back to symbols, and then we need to show that one. So show, and that was f triple prime, f 3 p's, close that, and then we'll go here and say evaluate. And there are derivatives, and in this case really nicely set up, and so we could always go back to Desmos and check, is that the same thing that we got back there in Desmos? So hey, why not? Let's check it out. We have minus 48x cubed. Okay, so I still have that graph with f triple prime on there, the absolute value of it. And so let's define h of x here. H of x is equal to, and we had a negative and a 48 x cubed. So x, and there we go, cubed. Okay, and then that was divided by, so divided by parentheses, and I think that was, I'll have to go back and check to make sure, but I think that's x squared plus 1. In that parenthesis, and then that was to the 4th power, I think. Okay, so I think I have that one. So let's check that. Minus 48x cubed, yep, over x squared plus 1 to the 4th power. And then plus, and we had a 24, and I think was that x squared, and then divided by x squared plus 1 to the third. Okay, well, so let's go back there. And, oh, just 24x. I had x squared. So, gotta get rid of that. Okay, and notice the black curve here, right over top of the green curve. Now, I didn't do the absolute value, but you know, we can see that that works, and if we don't believe it, we could always go here and do our absolute value of h of x, and then again, getting rid of this, we see that, you know, our red curve is definitely over top of the green curve. Okay, and so we can use Sage Cell to actually compute what that derivative is. If we don't necessarily need to know what it is, we can get decimals to just graph it. We could use the 2 to graph. Now you can graph within Sage Cell as well, but you know, the graphing in decimals is just really nice. So one last thing, could we have gotten this derivative here all at once? And so I'm just going to call this d for general derivative here, equals, and let's start with f. So f dot diff, and I may have to look this up, but I'm thinking that we can tell it, take the derivative with respect to x, and then do a comma and tell it how many derivatives we want, which is 3, and then close that off. Go down here and show that. Let's show d. D, and we'll find our evaluate there, and looky there. So I could have gone straight to a third derivative without doing the ones in between if that's what I wanted to do. So there we go. There's part 2 of exercise 48.